So the first thing to observe is that no non-tree edge can be a bridge. They have to be the green edges, not the red edges. And why is that? Well, the red edges are the ones that get added for a node that had already been reached by some other path. So the red edges can't be bridge edges because deleting the red edge, the node on both sides of this were reachable from the beginning some other way. Next, we can test whether or not a given node is in the subtree rooted at some node W pretty simply using the numbers that we've already calculated, the post order of W, the number of descendants of W, and the high and low values. And why is that? So when we go to do the post ordering at W, we go down here, we number somebody, then we number everybody, then we number W itself. The post order number of everyone in here has to be less than the post order value of W. But the total number of numbers in this set, they're all contiguous, they're all in order, and the total numbers of numbers in this set is blue, is the number of descendants. So black minus blue is one smaller than the smallest number in this collection. So that property is kind of obvious perhaps, but we're almost there. The only way that this edge is not a bridge is if there's some non-tree edge that takes us out somehow and connects to something else in the tree. Now, what would happen to the H value or the L value if we had one of these edges? Remember, the H value and the L value were defined specifically to be, well, you follow a bunch of green edges and then you follow one red edge. Well, if a red edge takes us to, sort of in the left of this tree, then the in-order value is going to be outside of this range, and in particular it'll be too small, and that'll tell us that we've linked to something outside to the left. If we link to something outside to the right, then the H number is going to be bigger than the in-order value at W. And similarly, if we hop up too high, that same thing happens because the blobs in here, the nodes in this blob, all have exactly the values in here. Anything that connects outside of there is going to cause either the H value or the L value to pop outside of this range. So with those values in hand, we have a very easy test to see whether or not there's some red edge that will actually connect up the graph in a way that this is no longer a bridge. And that's all we need to do. Now, in the homework, I'm going to ask you to actually carry out this test on a real graph, actually code it up. And it's not terrible, but it is a little bit tricky. You have to be very careful to figure out how to compute the post-order values, the number of descendants, H and L, without taking a lot of running time in the graph. Really needs to be able to do it essentially with one or two sweeps through the set of all the nodes and edges in the graph. But you can do it. I have confidence.